and get the whiteboard up. Okay, so let me kind of summarize what we are learning here. So if we have a vector, so let's say it's vector A. If I want to find, let me draw vector A. I'm getting a terrible delay again. Okay, so if we draw vector A, then we have AY being the opposite side and AX being the adjacent side. And so far, I have always been drawing these vectors in the first quadrant. Because in the first quadrant, it's really easy to see which trig function goes with which component. So for example, the opposite side goes, remember, SOHCAHTOA. SOHCAHTOA. The opposite side goes with the sine. And so we would have, you know, AY over A equals sine of theta. And so AY equals A sine of theta. And the way you actually do this is you don't always draw the ratio. You just ask yourself, you know that these guys are going to use the sine or the cosine. And you just say, which is this? It's opposite, so it should use the sine. And so I know it's going to be the hypotenuse times the sine or cosine. Because the AY is opposite, it should be sine. So I usually just use that logic to remember that AY is A times sine of theta. And if the y component is using the sine, the x component must be using the cosine. So what happens if we're in a different quadrant? Maybe we have a vector that looks like that. So if I have this vector, all of a sudden I can get a little confused how I should draw the triangle. Maybe I should draw it like this and have AY here and AX there. Or maybe I should draw it like this, and AX goes on top and AY goes on the bottom. If this is a 40-degree angle, then the AY would be opposite and it would use the sine if I'm using this lower triangle. But if I'm using this angle, then this angle will be a 50-degree angle. And the sine of that 50-degree angle will be looking at the x component, whereas the sine of this 50-degree angle looks at this y component. So my point is, when we're not in the first quadrant, we can get confused. Lucky for us, our calculator doesn't get confused by this. It's confused by something else we'll see in a minute. Let me just try to make that neater. But the calculator knows what's happening if we go into this quadrant, the second quadrant or third or fourth quadrant. It knows, for example, that we're still above the x-axis and the y component should be a positive number, but it knows that because we're to the left, the x component will be a negative number. Why is that? Because remember, the Cartesian form of the vector tells me the value of the ordered pair where the tip, where the head of the vector lives. And so I know that the x component here is going to be a negative number because I'm in the second quadrant. It's going to be negative there and plus there. So your calculator already knows this. So let's just suppose that this vector A has a length of 10, and I want to know AX and AY. All I have to do is use these same two equations. AX will be A times the sine of theta. The question is, which angle is theta? Is it the 40-degree angle or the 50-degree angle? And the answer is, and maybe you picked up on this from the lab, I hope so, but the answer is neither one is theta. Theta is that one. So if I have a 40-degree angle here, then this one must be 140 because it has, those two have to add up to 180. So to find the x component, I just have 10 times the sine of 140 degrees. And if we put that on the calculator, sorry, I said sine, but I was meaning to do the y component. I wrote AX, but I meant to do AY for this. And what we get is 6.43. And then to get AX, I do the same thing, but using the cosine. That's going to be 10 times the cosine of 140. Which is negative 7.66. So the idea is, just 1 second, Blair. The idea is by using an angle from the x-axis, that's 140 degrees, the calculator knows how to interpret that. It knows that we are in the second quadrant and that we should therefore get a positive number for the y component and a negative number for the x component. Blair, your question. Blair, did you have a question? Oh, okay. Yeah, so although this stuff with the sines and cosines and tangents and opposite and adjacent and all of that, it's complicated if you've never seen it before. The bottom line is once we understand it, we just kind of learn to always use the sine to get the y component and the cosine to get the x component. And as long as we've practiced it, we'll be doing pretty well. So the catch is we have to measure our angle from the positive x-axis. So it doesn't really make conceptual sense to say the sine of 140 degrees because there's no right triangle with a 140-degree angle in it. But mathematically it makes sense. I mean, or that is, our calculator knows what we mean as long as we make this agreement. We will always use the cosine for x and always use the sine for y and measure our angles from the positive x-axis. Then, no matter which way the vector is pointing, we can always get its components and we'll get the sines right as well. Now, some of you may have learned how to do sines, cosines, and tangents already in another class, and you may just use SOHCAHTOA. That is, you draw a triangle and you think opposite and adjacent, and that's totally fine. If you've been doing that already in your past math life and you understand it and want to do it that way, that's great. Do it. Be sure to be careful at the end when you get a number and check the sign of your answer to make sure it matches the quadrant you're in, because it's easy to make an error and forget to check that. That only becomes really important once we start adding vectors up. But if you haven't really done this stuff very much, then I would recommend, although you need to sort of understand both approaches, I would recommend just using the formula. because it will always give you the right answer and it will always give you the right sign. That is plus or minus sign, S-I-G-N sign. Okay, any questions? Haley, will these formulas be on the sheet for the test? Yes, 100% absolutely, they will be. As well as we will have inverse tangent, or we'll have theta equals inverse tangent of a y over ax. Because the same exact logic, when we leave the first quadrant and go into other quadrants, your calculator is also sort of pre-programmed that as long as you put the y component over the x component, it knows what you're talking about. So for example, if I use my calculator and I say theta equals the inverse tangent of 6.43 over minus 7.66, the calculator knows what I mean by that, okay? And up to a point. Now here's where our brain has to do some work for us because we are smarter than our calculator. Now 6.43 divided by negative 7.66, and I do the inverse tangent of that, and I get negative 40 degrees. So our calculator, in this case, gives us the wrong answer, okay? Now, unfortunately, this is a weakness of calculators when it deals with inverse trig functions. And you don't have to think too much about, you know, mathematically why this is. But basically, the calculator gets the angle wrong 50% of the time, okay? 50% of the time, it's correct, and 50% of the time, it's incorrect. And here's why. Because the calculator cannot tell the difference between 6.43 over negative 7.66 and negative 6.43 over positive 7.66. So one of those would be down here. If it's, you know, if the y component is minus 6.43 and the x component is 7.66, that would be a negative 40-degree angle. You know, the calculator cannot tell the difference. It can't tell where that minus sign is. So that's why we have to use our brain and be smarter than a calculator. So when I do this and I get negative 40, at the end I have to say, well, is that in the correct quadrant? Because I know if I have a y component that's positive and an x component that's negative, I must be in the second quadrant. So if the calculator doesn't give me an answer in the second quadrant, then it is wrong. And what I have to do is just add 180 degrees to fix it. Because when it's wrong, it's always exactly on the opposite side of where it should be. Okay? Now that's true when you're doing inverse tangents. If you use an inverse sine or cosine and it gives you the wrong answer, you cannot get the right answer by adding 180. You have to actually kind of think about it a little more and maybe draw a picture. That's why I recommend we only ever use the inverse tangent for finding angles, because if it's wrong, we can always get the right answer by just adding 180. Okay, so here's a general rule how to know whether your calculator is going to get it right or wrong. The calculator is, I'm going to use colors to kind of illustrate this. It's right on the right, and time lag there. It is wrong on the left. Okay, so if the actual vector is on the right half of the plane in the first or fourth quadrant, the calculator will give you the right answer. But if the answer is on the left half in the second or third quadrant, it's going to get it wrong. Every calculator on Earth that I'm aware of will always get it right on the right and wrong on the left. So we need to be able to draw these vectors and visualize them, in part because we need to be able to assess our final answer and know if the calculator is leading us wrong. It's not good enough to just use formulas. It's not good enough to just draw pictures. We have to be able to do both approaches. Okay, any questions about that? Is anyone in here, did anyone already know that the calculator gives you the wrong answer on inverse trig functions? Okay, yeah, I don't think a lot of people realize that in math class. Okay, so let's now practice putting it all together. So suppose we want to add a couple vectors. Oops, I want. One more try. Okay, so suppose I have a vector A, which just points along the x-axis. And maybe it has 10 units long. And then I want to add to that a vector B which is 15 units long. And there's a 45-degree angle. And I want to find the sum of these two vectors. So to find the sum, graphically, it would mean just picking up A. I'm just going to copy it and paste it. Oops. And just moving it. Come on, stop. Stop. And then we find the sum of A plus B is a vector that goes from the origin to sort of the end point. If I walk along vector B and then I walk along vector A. So graphically, I feel like the answer should be, this is my guess. So we often call the sum in our problems, it's called R. If you look in the book, R stands for resultant. The result of adding. It's the same as what the lab meant by the sum vector S. So I'm going to say R is going to be about, I think it's about 10 units, and the angle for R is going to be about 93 degrees. So this is my guess based on drawing the picture. Now, I didn't measure out how long A and B were, so it's possible that maybe the angle's really more like 85 degrees, or maybe it's really 100 degrees. But this gives me a ballpark idea. Now I want to add them. To add them, I cannot add them in the polar form. I have to find AX and AY and BX and BY. Okay, so for AX, it's actually really easy if you know how to work with vectors. If you're new to vectors, it may not be obvious, but the X component is just 10. Because the whole thing points 10 units along the x-axis. The coordinate of the tip of this vector would be the point 10, 0. I can see that from the graph. However, if you can't see that from the graph, then you could just say AX equals A cosine of theta, which is 10 times the cosine. Does anyone know what is the angle for vector A? Can anyone tell me what the angle for vector A would be? It's a little tricky because it doesn't look like it has an angle. Anyone know? What if you just could guess and you win $10 if you're right, and if you're wrong, you win $5? What would you guess? Sam?
135.
You're guessing for B. You're guessing for B, and for B I would agree with you. So this is 135, but I'm talking only for A here.
Really?
Say that again.
Is it nothing?
Yeah, it's 0. So just 0. And if you put in 10 times the cosine of 0 in your calculator, you get 10. And if you put in, to get the y component, 10 times the sine of 0, you get 0. So the formulas work even if it's not jumping out at you. But after you've practiced a little, you're going to see that if a vector lines up with an axis, if it lines up on the x-axis, it has no y component at all. Its y component will be 0. And if it lines up with the y-axis, its x component will be 0. So you'll get some practice when you do the homework there. But if you're not sure, work it out with the equation. For vector B, we are going to have 15 times the cosine of 135, just as Sam said. And that is minus 10.6. And then we're going to have 15 times the sine of 135, which is positive 10.6. So this is just the calculator telling me that the x component should be negative because I'm in the second quadrant. It knows we're in the second quadrant because we put in 135 degrees, and the y component should be positive. So now to find Rx, we just simply add Ax and Bx. So that is 10 plus a negative 10.6. That's going to be negative 0.6. To find our y, that's going to be ay plus by, which is 0 plus 10.6. That's 10.6. So what exactly are Rx and Ry? In my picture, we may maybe write our vector on that side and our y here, and our x is this little bitty bit on the top. And to find the magnitude of the hypotenuse there, we just use the Pythagorean theorem. It's going to be the square root of negative 0.6 squared plus 10.6 squared. And that's, well, 10.6. It's like 10.62. And the angle would be just the inverse tangent of my y piece, and that's for the vector r, so that's 10.6 over negative 0.6. Make that a little neater. Putting that in my calculator, I I get minus 86.8 degrees. And the last thing is to check, does that make sense? Does it make sense that the angle, where's minus 86.8? It's down here. But my r vector is not down there. So it does not make sense. So I have to add 180. And I get 93 degrees. So my guess, and I really just made this problem up, I guess, so I was actually expecting to be off by more than this. I got a little lucky, I would say, but my guess was pretty close. Now, if I got for R 12 and the angle was 100 degrees, that's close enough. I would think, okay, I'm doing the right thing. But by making a guess up front, if I'm thinking the angle should be 93 degrees and I got minus 86.8, that tells me something's wrong. And the something wrong in this case is the calculator again. All right. Any questions about that? Okay, let's try another problem. So suppose we have a vector A with a length of 15 and an angle of 20 degrees, and a vector B and the length of B is, I'd say, about 7, and this angle is 70 degrees. And then a vector C this one a little thicker so that we can see it a little better. C equals 10 degrees, or 10 units, and it points down the negative y-axis. And we want to find the sum, which would be, maybe we could do A minus 2B plus C. So this is now a vector equation. How do we do it? Well, the key is to find AX and BX and CX. And in general, we're going to have RX equals AX minus 2BX plus CX. And RY equals AY minus 2BY plus CY. In other words, we find the components, and then whatever the mathematical equation is for the vectors, we get the same equation for the components. Now, graphically, if I want to add these up graphically, I'm going to go to a different page for that so that we have a little more room. And our equation, just so we can see it. Okay, so there's our equation. So how do we graphically add these? Well, what this says is walk along A, and when you get to A, you make new axes. right there, because it's like you're reading a compass. And when you walk along A, you're still looking north. North is up here, not back over here. So north is always directly north of where you are. And then we take the vector B and correct. And we want to move it here, but we want to rotate it around. Stop rotating. So that we're subtracting it instead of adding. And we want to do 2 of those. So let's rotate that around. Okay, so there is my 2b. It's not exactly perfect. So if I were adding 2b, they would have been like b and b. But this is what I'm doing when I subtract is I'm adding negative b and negative b. I can get rid of those weird angle things. So subtracting a vector is like adding the opposite of the vector. And then finally, we want to take c and move that to the end. So we're going to copy it, paste it, and sorry, this process is so slow. Be easier to draw it, I think. Okay, and finally then the r vector, the resultant vector, will look like that. So now if I want to estimate the angle, I'm going to estimate it's maybe negative 42 degrees. And the length of it, I think it's maybe, I don't know, 25. So that's my guess based on my drawing. Now we have to actually find all of the components. So what I'd like you to do is to maybe spend about 5 minutes each of you individually and try to work out the components of these vectors. So we want to know AX, AY, BX, BY, CX, and CY. So this is the task we have to be able to perform before we can start adding those components up. So go ahead and take about 5 minutes and try to work that out. And I'll work it out while you're doing it. Don't look at my answers, just work out your own answers. In fact, I will save you from the temptation. Whenever you have answers for all three, raise your hand. Okay, who has numbers for A? Okay, Blair, what's your number? What are your numbers for A?
14.1 for A of X and then A of Y 5.1.
Okay, that's what does anybody have, anyone else have numbers for B? Here.
I had negative 2.4 for B of X and B of Y 6.6.
Okay, that's what I've got as well. And anyone with B? Anyone else? Okay. Blair, what did you get for C?
I got 0 for C of X and C of Y negative 10. Is that right?
Okay. Yes, that is correct. So let me put mine up. Okay, so I didn't show the work, but you know, for A it would be 15 times the cosine of 20, or 15 times the sine of 20. And for bx, it's going to be 7 times the cosine of 110, or 7 times the sine of 110. And for C, we can do sines and cosines again. The angle would be 270 degrees, so that would be 10 times the cosine of 270 and 10 times the sine of 270. But I really encourage try to work on intuition. Why is it that CX is 0? Because C doesn't point left or right, and CX is telling us how far left or right it points. Why is CY negative? Because it points down. And why is it negative 10? Because it's 10 units long. So it points down 10 units. once we have that information, we are able to find Rx, which is, AX minus 2BX plus CX. And that's going to be 14.1 minus 2 times minus 2.4, and then plus 0. So that looks like, I'd say, 18.5. You should check me out there. 4.8. I think that's 18.5. And Ry is going to be 5.1 minus 2 times minus 6.6 plus a negative 10. Sorry, it's a positive 6.6 inside of here. So I get minus 18.1. Anybody get the same numbers that I got for Rx and Ry? Grace? Okay, good. So then we can find R. Let's move down here since we have room. It's going to be the square root of 18.5 plus a negative 18.1. Now remember, if I squared the negative 18.1, I have to square the minus sign as well. Let me see. 5.1 minus 2 times 6.6. Minus 10. I am getting, Rx, is it? Yes, it should be 18.9. Thank you. Okay, good. So that's the 18.9 squared. Thank you, Allison. So what do we get when we add these guys? Remember to square the minus sign on the 18.1. And this is 26.2. And the theta for R is going to be the inverse tangent of the y piece over the x piece. It's always y over x. We get minus 43.8 degrees. And then finally, remember with this angle, I have to ask if it makes sense with my picture. Well, I thought it would be minus 42, and it's about minus 44. So it's definitely, all I'm asking is it in the right quadrant? It's in the right quadrant. It's pretty close to what I expected. I guessed a length of 25, and it's 26.2, and I guessed an angle of 42, negative 42, and I got minus 43.8. So this is a problem that on the contest, I'm selecting it because I feel very confident that we did the right thing. Even if I made a small mistake like 18.5 instead of 18.9, that would be at most 1 point off. So, we want to build an intuition through drawing these pictures, but ultimately, we want the skill of adding vectors, not for its own sake, but because as we go through the semester, we are going to have to be able to work with vectors. So your job for tonight is to do the homework that's listed for tonight, practicing finding components of vectors, adding the vectors together, and then at the end, finding the magnitude and angle of the resultant vector. And if you master all of that within the next, I'd say 2 days or so, you will be in very good shape to move forward into the next, really the next 3 chapters rely on this material pretty heavily. Okay, does anyone have any questions? Elise.
So for the equation that you got, r equals a minus 2b plus c, is that just something like that you knew, or how did you get that equation?
This right here?
Yeah.
Yeah, that would just be like a problem. You know, if in the textbook you might be shown a vector a, b, and c, and it says, okay, find the value of a minus 2b plus c. So that's
Okay.
just like a particular problem.
Okay.
Yeah, it's an example. In real life, these vectors will be forces, and so there will be like a really good intuitive reason why we're adding them. But for right now, we're just practicing. Haley.
Okay, my question was about, I know like on another practice problem we did, we had a vector that was like straight along the x-axis, and we said that that was an angle of 0. So it's only if it's on the x-axis that's an angle of 0, not if it's straight up and down on the y-axis. Is that correct?
Yeah, so basically this axis is 0, this would be 90 degrees, 180, and 270. So if I have a vector that's pointing here, that angle is going to be 90 degrees. If I have a vector that points like this, that angle is going to be 180. And if I have one pointing down here, it's going to have a 270. Does that make sense?
Yes, thank you.
Yep, okay. So really what you're asking is how far do you have to go to get to that vector? So for the orange vector here that's on the positive x-axis, you don't have to go anywhere from the axis. You don't have to step off of it to get to that vector. So you have a 0-degree angle. This one is at 90 degrees. That one, you have to go all the way around 180. And the third one, you have to go 3 quadrants. You have to go 270 degrees to get there. Okay, other questions? All right, so, you know, practice. If you're having, oh, Ziad?
Sorry, I was muted. Just a quick question. When we came up with like the graph and we were trying to visualize the vectors, that was based off of the formula that we were given, like when we first started.
So on the last problem,
yeah,
right here? Yeah, absolutely. So we had a minus 2b plus c. So I start at the origin, I walk along vector a, and then we make a new origin at that point. And then at that origin, I took the vector b and I flipped it around to get a minus b. And then that kind of gets its own new origin. And I had to do that twice because it's minus 2b. And then we kind of make a new origin at that location, and we take vector c and we move it down and place it at that new origin. And then it's like we were imagining we're following a pirate map. You know, you walk 15 miles in this direction, and then you turn and you walk, you know, 7 miles twice in this direction, and then you go 10 miles south, and then you're like, where am I? Where are you relative to your starting point? That's what the red vector is indicating. Where are you relative to your starting point?
Okay, thank you.
Uh-huh. Any other questions? Sarah?
So for to get like C values, I use -90 for the angle. Is that applicable to kind of like that way for every problem?
Can you speak up? I couldn't quite hear you.
Oh, I said to find the C coordinates, I use -90 instead of 270. Is that
Yeah.
applicable to use for like?
Absolutely. You can, that's a really good question. You can think of this one as, negative 90, and this one would be minus 180, and you could even go like minus 270 to get the positive y-axis if you were thinking that way. So yeah, you can use, the calculator knows that minus 90 and 270 are the same. So they're both just as good.
Okay, thanks.
Sure. Any other questions? Okay, so please practice that stuff. I will be putting up our next lab sometime tonight, which is on projectile motion. And again, it is, going to help us explore. I think it's due on Wednesday, maybe. And just, for those of you who maybe you didn't have quite the score you were hoping for on this last contest, I think the next contest should give you the opportunity to show a little more what you can do, because we'll be finishing that material on Wednesday, and you can work on Wednesday and you can come back on Thursday and ask questions, and we didn't have that opportunity for the first contest. So it was very tight timing wise, and you'll have a little bit more time to try to absorb this material, because as I said, we should finish it Wednesday. On Thursday, I will introduce new material that won't be on the contest, and so you have kind of an extra day buffer to prepare and study. But still, I would really recommend trying to stick to the homework schedule to make sure that you're prepared for this next contest. I will go ahead and stop the recording, and if anyone has individual questions about your contest or anything else, you can stick around. Or if you're offline, send me an email and I can meet with you. Thanks a lot.